Okay, this problem is an exponential, but it's one that doesn't have a base e. There's a base 7, and therefore it's a little bit unusual. One other unusual feature of it is that one term in the exponent is a square root, a radical. So I'm actually going to write that as x to the power of 1/2. Okay, so anytime in calculus that you're dealing with square roots, rewrite them as powers because it's going to be a lot easier for you in the long run. And at the end we can convert it back. So if f of x is equal to 7 to the power of 3x minus x to the power of 1/2, and we differentiate, well, the derivative of f of x is f prime of x. Now the basic rule for an exponential that has a base other than e is to keep everything exactly the same. So we're going to start off by keeping everything exactly the same, and then we multiply that by the natural log of whatever the base was. So in this case it's 7. So that's the basic rule. But of course there's always something else, and in this case we have to multiply that by the derivative of whatever the exponent was, the derivative of the power. So, and because there's more than one term, we're going to have to put this in parentheses. So if we differentiate 3x, we're just going to get 3. And if we differentiate negative x to the power of 1/2, that's going to be multiplied down to the power, so negative 1 by 1/2 is negative 1/2 x to the power, reduce the power by 1, negative 1/2. Okay, it makes a little bit more sense if we rewrite this, and I know it looks a little bit unwieldy, but since the original question had a radical on it, it's nice to put this back in the same form. So it will be 7 to the power of 3x minus x to the power of 1/2, that's just the square root of x, by the natural log of 7 by 3 minus this here. We're going to rewrite that. We've got 2 in the bottom. X is a negative power on it, so the x goes under the line as well. And the power on it was 1/2, so it's the square root of x. Okay? And it's a horrible looking mess, but that's just what's going to happen sometimes. I have no idea what you would use that function for or where it would arise naturally, but certainly we need to be able to manipulate it and to differentiate it just in case we ever would come across it. Okay, thank you.